Thank you very much. The importance of local knowledge and understanding for building resilience to coastal change. It's a topic I normally don't talk about. I'm a scientist. I'm an underwater geographer or a shallow water oceanographer. Lead the scientific data analysis component on the Making Space for Sand project. So what I decided to do was to frame my presentation as follows. Local communities on the right, coastal councils, Environment Agency in the middle, and then the scientists and the coastal consultants on the left. Decisions about how the coastal zone is managed through plans, policies, or schemes come directly from the coastal authorities. Ideally, we want a system where we have errors going from the different people involved. So we want coastal communities to feed back to coastal authorities. We want coastal authorities to communicate to coastal communities. For coastal communities to be a respected partner in this process, they need to develop coastal literacy. They need to have some basic understanding of the coastal environment, what's happening. And my argument is they need specifically also to understand what's happening at their local site. And they're in an ideal position to have that knowledge. And therefore, there's also arrows from the consultants to the scientists to the coastal communities. So the aim of my talk is not really to tell you that this is important, because I think you realize this is important. You're all sitting here. I just want to convey to you how important it is by showing some examples of coastal change in Cornwall as part of the Making Space for Sand project, where the local knowledge is so absolutely critical in trying to figure out what's going on and how to solve things. Again, this is a really important diagram that I don't think gets shown enough. It is the rate of sea level rise measured at Newlyn over the past 100 years, and we see this line creeping up. Most importantly, we see this line accelerating into the future. Justin already talked about this. This is not up for debate. This is a fact. This is happening. We don't really need to have an argument about this. And then we have these predictions that the Intergovernmental Panel for Climate Change makes, and then they get customized by the UK Met Office to make them specific to the UK. And they basically show increasing rates of sea level rise. Justin talked about this as well. You know that the outcome will ultimately depend on which scenario, which emission scenario is being followed. But we already basically signed up to about a meter, maybe up to a meter certainly by the next sort of 100 years, possibly more. But it's definitely not going to be less. So again, you can argue about where this number should be, but again, we all know about this, and we can plot curves on temperature, we can plot curves about rainfall variability, we can plot curves about stream flow. It's all going in, I guess, the wrong direction. And again, they're not really up for debate. Is how do we deal with it? That's really the challenge that we're faced with, and we can argue about how we do that. Now, what is the implication on the coast? I was warned not to put this slide up because it looks quite technical, but it is actually quite intuitive and a simple representation of what happens as sea level rises over a coast that consists of sandy beaches and sandy dunes. You see the line, this line is basically the underwater profile of the beach, so the beach going down underwater. We have a sea level, which is the solid line, and then if we raise sea level, which is the dashed line, this diagram actually shows what happens to the coast. And in very simplistic terms, the coast will move up with the rising sea level, and it will move back with the rising sea level. And we can see this happening at a coastal dune system during storms. Sand is being taken from the front of the beach or from the dune system and gets often moved offshore. Now, the nice thing about this really simple conceptual model is that we can quantify, which means we can estimate the number of retreat relatively easily with this approach. Now, this is not a perfect approach. It's a very simplistic approach, but Justin mentioned NSERM lines and sort of government policy about coastal planning. They use this sort of approach. So it's not like it's not being used because it's simple. It's actually quite simple, and therefore it's being used quite widely. And all we need to know really is the height of the dune is important. The higher the dune, the less we have retreat, because there's all that sort of this store of sand that can sort of help the erosion, and the width of the beach, I guess, and sort of the height of the beach. Details are not really important. There are three very easily quantifiable and measurable parameters. We put them in a very simple equation. It's just a ratio, multiply that by the amount of sea level rise, and we get an estimate of how much retreat we can expect. Now, I'm sure you understand that that is actually quite useful to know how much the shoreline retreats, because then we can try and adapt to it or do something about it. So it's a really important number. But like I said, it is very simple, and it ignores a lot of really important site-specific features, and that's what I'm hoping to demonstrate. So the Making Space for Sand project looks at 40 sandy beach dune sites in Cornwall, and our role on the project is to study these dune sand systems, these beach sand systems, to sort of try and work out what's going on with the movement of the sand from the beach into the dune, maybe from the dune to the beach, between different beaches, to basically get an understanding of the coastal dynamics, and then use that understanding to develop tools and methods and models to then predict what the coastline will do in the future, and to refine this very simple approach that I showed you earlier. That is sort of our role on the project. Now, one thing we did is to use the data that's already been collected for the last 20 years by the Southwest Coastal Monitoring Program. They basically measure the dune systems and many locations in Cornwall. They survey it every 6 months, and that tells us about how the dunes change over time. By looking at how the dunes have changed over time, we can tell us something about how they will change in the future. Now, this is a key result. I think it's a really interesting depiction of what's happening on our dune systems in Cornwall. So what is shown here on the left is the changes in dune volume, which is the changes in how much sand is there in the dunes. Are they really big and full, or are they small and low? And the one on the right shows the changes in the position of the dune on the beach. So whether the beach is retreating or whether the beach or the dunes are building out. The bubbles are all the different sites. When you see a red bubble, it actually means that the dune is shrinking in size. The red bubble here means the coastline is retreating. A blue bubble means the dune is gaining in size and the shoreline is advancing. And the size of the bubble gives an indication of the magnitude of change. If the simple model that I showed you earlier applies to all the dune systems, because we've had about 15 to 20 centimeters sea level rise in the last since the 1990s, all the bubbles should be red. And they should be more or less the same size, and maybe slightly larger sizes for the low dune systems and slightly smaller sizes of bubbles for the high dune systems. You can see it's basically a huge variety of colors and a huge variety in sizes, which already tells us something about that these general models that are used on a national and even a global scale to predict where the shoreline will be, they're unlikely to be particularly applicable to many of the sites. So the local knowledge here is really key in explaining why they're not all red bubbles. And if you want to predict what these dune systems are going to do in the future, you have to take into account what's happening at the moment to some degree. So I'll show you some examples of what are the site-specific factors that really mess up that sort of correlation, that mess up this prediction. Summerlees, and I'm presenting, I think, 8 diagrams, 8 localities in exactly the same way. It's an aerial photograph. On top of that, you see colors, either blue or pink. They are quantifying, they are depicting the change in the dune surface. Pink means the dunes are going down. Blue means the dunes have built up. And then you see a dashed line, black line, and a solid line. Now, the lines are where the beach and the dune intersect. I call that the dune toe, or the toe of the beach, or the toe of the dune, whatever you call it. So retreating or advancing. The dashed line is like 15 years ago, and the solid line is now. So for Summerlees, we see interesting things. We see a lot more blue than pink. Basically means the Summerlees dune system is gaining sand. Sand is being blown into the dunes from the beach. At the same time, we see that the shoreline as a whole is retreating. So the dunes are being pushed back and they're growing at the same time. That's already a bit of a contradiction, isn't it? Because if the dunes are retreating, you'd expect the sand to go offshore. But actually, there's also sand going into the dunes. And people who live there know it because it's engulfing the car park. They don't want that. So why is this not working according to the model? Well, we've got the river channel messing things up. We've got management like bulldozers and coastal structures and blocks of concrete have been dumped on the beach in the past, which mess things up. Perhaps most importantly, that Summerlees has a mining history, that people used to take sand off the dunes and Summerlees for the calcium carbonate that's in it. So maybe that's always been like a developing dune system, and they kept taking the sand away. They stopped taking the sand away, and now the dune's recovering. I don't know how much sand was removed, when it stopped, when it started, but it's also a factor. The Camel Estuary, we have two really nice dune systems. I keep forgetting the name. I keep calling it Harbour Beach. It's not right. And then we've got the rock dunes. They're inside Padstow. That's the dune system that's actually building out massively. The black line is much further out than the dashed line. The whole area is blue, which means sand is being blown into these dunes. It's one of the two best developing dune systems in Cornwall. And then the rock dune system, this delta-shaped dune system, is basically being pushed into the estuary. It's eroding at the front here, and then it's building up at the back, but it's on the whole, it's losing sediment as well. Well, what's going on here? Well, it's got nothing to do with sea level rise. You know, any prediction based on this Brune rule, this model approach, is not going to work at all, because we've got river channel massively affecting what's going on here. We've got dredging going on, affecting the sediment supply. So if you want to, predict what's happening to those dunes, forget about rising sea levels. Other things are going on here. Local knowledge, really important. Perranporth. Interestingly, the whole dune system at Perranporth is blue. The coastline is also retreating. So we see this dune system increasing, but slightly retreating at the same time as well. So, some element of sea level rise, but it seems to be having what's called a positive sediment budget. Sediment's going into the system. There's a lot of landscaping going on. The watering hole, they're very busy with bulldozers moving sand from one place to the other, probably pushing it into the dune. They don't want it here because it blows into the cafe, so they chuck it at the back. And then we have a river channel that also messes things about. So again, local factors are really key to explaining what's going on there. Crentock is it's a legendary site now. I can't quite explain it, but there's so much losses of sediment from the dune systems, much more than you would expect on the basis of a 15 centimeter sea level rise. There's some fundamental changes happen there, and partly due to the river channel that used to go along here, then it shifted to that side. It lowered the beach in front of the dune system, made it easier for the waves to reach the dunes, making it more difficult for sand to be blown into the dunes because the sand's always wet. So we have a completely different explanation for this side as well. Fistral actually behaves quite as you should. The amount of retreat at Fistral is sort of in line what you would expect of a sea level rise of 15 centimeters, but you can also see this ribbon of blue. So there's also some sand being blown into the dunes here as well. The Hale Estuary, very much like the dunes at Padstow, a complicated picture with blue and pinks all over the place. Again, much related to the dynamics of the Hale River Estuary. So again, not much to do with sea level rise, but more to do with the amount of sand that's being dredged from the Hale. Where is it dumped then? Really important as well. Are there any sort of changes in the position of the river? That's all really key in explaining what's going on there. Brass Sands, which I don't even call a dune system. It's actually a very low dune system on top of a coastal cliff. So it's a completely different sort of process that are going on there. The cliff is being cut back by waves and sea level, but it's a different sort of model that one should use. And then two more. Poldhu, nice little beach, seems to be very stable, but again, gaining in sediment because the whole area is blue. Again, it bucks the trend a little bit. There's no pink at all in that sea. And the final one, the really old one out, is Brass Sands, which has been building out massively. The whole area is blue. It's meters per year almost it grows. And the reason why it does that is because it has a very large positive sediment budget. It means a lot of sand is coming from the underwater part onto the beach and then from the beach into the dune. Why is that? Well, there's a mining history there. We did some underwater survey work offshore of Par. There is 6 meters of sand sitting there at 15, 20 meter water depth, and it's sitting on rock. Now, it didn't get there by natural processes. It got there by as a legacy of the mining, the China clay mining legacy. And now that sand is just sitting there. It's not supposed to sit there, and it's gradually being pushed to the beach, and then the wind picks it up and tucks it into the dune. So again, completely different. Local knowledge, absolutely key. So what do we do with this? Final slide. Well, we've been asked to predict where's the shoreline in 2050, in 2100, because if we know where these zones are, then we can decide not to build in these areas. We can decide to protect or not protect, depending on what is in those sensitive areas. So when Justin talked about shoreline management plans and CCMAs, those sorts of policy have to be informed by what the shoreline will be doing in the future. And just blindly applying a very simple model, in our view, is not the right way to go about it. So we advocate that what you do is you use the actual measured data that you have, which costs a lot of money to collect. Let's do something useful with it. Use for the first 10, 20 years, the medium time scale that Justin talked about. Just use the extrapolate, so just continue the trends that you've observed in the past. Maybe use that as a guideline for where the coastline will be in the next 10, 20 years. And then for the long time scale, because you don't know whether these trends will continue, sediment is going to run out at some point. People will stop messing with the river maybe. Maybe for this long-term timescales, you use the predictions as a fallback. And then in 10 years' time, you have even more data. You've got 30 years of observational data. You basically revise your projections and you just keep moving that forward. So here we have observations for Summerlees. This would be our 2040 projection. The red, the pink line to the would be the middle of that, sort of, because there's some uncertainty about this as well. And then on the 100-year timescale, we used a computer model. It's just a different way of going about it. Actually, use the local knowledge, the observational data that people have painstakingly collected, that we've analyzed, to actually inform what will happen in the future. So take-home messages really is I can read from this, but I need to put my glasses up. So coastal beach and dune systems in Cornwall are highly diverse. I mean, every dune system is very different. There's 40 of them. They're all very different. Some of them are a bit similar, but actually every dune system is unique. Sea level is rising, and there are general principles that govern the impact of sea level rise on the coast, that rule that I showed you. However, site-specific factors can be far more important in determining the coastal evolution. Sediment supply, river channel dynamics, human interventions. And really the key message to you is really for coastal communities to be involved with decisions about coastal management planning. I think they need to be informed about generic and local coastal processes and issues in some detail. You don't need to become experts, but you do need to have the coastal literacy to be able to sit around the table with engineers that present model results. You should almost be in a position that you can question the model results because you've got that coastal literacy. How you achieve that, that's not what my talk is about. But I guess one way of achieving is by getting people like me to talk to you. But so that's a different story. But a baseline level of knowledge and understanding, I think, is absolutely essential to have an informed input into the whole local planning process. Thank you.